we're going to look at surface area formulas and the shapes associated with them. So the first shape we're really going to look at is looking at what we call prisms. So it's a three-dimensional shape that have a common face throughout the length or the height of what we call the prism. The common face is also known as the base of the shape, and the distance from the face to the face is the height of the prism. So I know that sounds complicated. Let's just look at some different types of prisms. So we have something called a rectangular prism because we can look at the base shape. So if you look at the base down here, you can see that it is a rectangle that has a length and a width. And then you see that throughout the height, we have the exact same shape. So as you sort of make cuts along the shape and you go right to the end, you have the exact same shape on the other end. So this is what we call a rectangular prism because we have common faces that are the same, and throughout the shape, it is that exact same face as you go. If you look at the same rectangular prism, but you look at the side instead, so if you make this your common face, then same thing happens throughout sort of the length of the shape. We have the exact same face on the other side. So again, we're seeing that sort of prism idea. And it doesn't necessarily have to be a rectangle. It can be any other shape that you can take a look at for your common base. So for example, a triangular prism. So looking at this shape, which one continues throughout the whole thing? You can see that if you look at this as a base, a triangle, then throughout your entire length, you have the exact same shape happening, and on the other side, you have the exact same base. So again, what we call the base or the common shape throughout the entire prism. You could also have a cylinder, which has a circular base. So again, if you look at the base, the bottom is a circle in sort of a two-dimensional shape. Throughout the entire height of the cylinder, we have the same shape happening, and we have the same common face on the other side. So notice in terms of what we call surface area, we have that lateral surface area, which is around the shape. So in this case, it would be all the three sides. And then your total surface area would add in the ends to it. So it would also include the two triangles or the two bases associated with it. So we have a pretty standard formula associated with prisms. So that formula is going to be for lateral surface area, or LSA, we have P times H, where P is the perimeter of the base shape and H is the height of the prism. For total surface area, we use the LSA, so the lateral surface area, and then we're adding 2 of our bases, so 2 area of the bases. So again, we can go back to that reference sheet and be able to use our formulas associated with area of the base. So whether that's a rectangle, whether that's a triangle, whether that's a circle, whether that's a hexagon, you can do that same thing for any kind of prisms that you're dealing with. The other shapes we're going to look at is right pyramids or cones. So a right pyramid has a base that is a rectangular polygon, but we no longer have that throughout the whole shape. We actually have 3 or more lateral faces that taper to a single point or an apex centered over the base. The altitude of the height is the perpendicular distance down, and then we also have what's called a slant height along the base or along the sort of lateral surface area component. Cones are very similar to that, except they have a circular base obviously associated with it. So let's look at a couple shapes associated with that. So you might have again a rectangular pyramid. So I'm just going to sort of draw the rectangular part in the back there. So again, we have this base on the bottom. So we have a base that is a rectangle, and then we have these sort of slants along the way. So if you are looking at the idea of heights, we have what's called a slant height, which is along the side. So this would be our slant height along here. And then if you look at the apex up here and you drop it perpendicular to the base, create that 90 degrees, this is what we'd call our height or our altitude. So similar in a cone, same kind of thing happening there. We have a base that is a circle. And again, remember that we have a diameter and a radius associated with that. So again, we have our slant height along the side of the cone. If you drop your perpendicular height down, that would be what we call your height or your altitude. And again, we have standard formulas for that. So your lateral surface area is P times S divided by 2, where P is the perimeter of the base, S is the slant height. And then TSA again takes that lateral surface area and it adds the base. And in this case, there's only one base, so we're just adding 1A associated with that. And finally, the third shape we're going to look at is a sphere. So there is no base for a sphere, and there's no distinction between lateral surface area and total surface area. It's just the surface area of the entire thing, so there is no sort of base associated with it. So again, we don't really talk about lateral versus total, it's just surface area of a sphere, and there are two formulas associated with it. So you can either use your radius, so it's 4 pi r squared. Remember, radius is half of your diameter, and then you could use the diameter formula instead, which is just associated with it. So you can use pi is d squared or diameter squared. So again, choose your options in that case, and remember to use your pi button on your calculator so that you can use all the decimal places until the very end of the question.